Hello, students. Welcome to Target Global Academy and the chemistry session. So today we are going to do the organic questions. So basically the very important questions. Okay. So which is asked in the previous year questions, and also when you study the organic chemistry chapters like haloalkenes and haloarenes. Okay. And alcohol, phenol, and ether. Okay. And aldehyde, ketones, and carboxylic acid, finally amines. And this session, most probably, we will include our biomolecules also, since biomolecules is not a very high weightage chapter, it is an easy chapter. Okay. So let's go with our discussion. So first of all, we are starting with haloalkenes and haloarenes. So what are the important things in haloalkenes and haloarenes? While studying, you should go through this part. Okay, we can say that this chapter contains many hotspots. Okay, mainly many kind of many kind of important questions can be asked in haloalkenes and haloarenes. Okay, suppose if you are taking allylic halide, like that classification is highly important. Allyl halide, vinyl halide, benzyl halide. Many times MCQ questions are asked. For example, allyl halide. Okay, so what do you mean by allyl halide? Halide means halogens, fluorine, chlorine, bromine, iodine. These are halogens. Okay. Okay, you can see. Suppose, so this is a haloalkene. Okay. Suppose, this carbon, the halogen attached in carbon, this carbon is sp3 hybridized, but the nearby carbon is sp2, right? So not the next, not the halogen attached carbon, but the next carbon is sp2 hybridized carbon. Then that kind of halides are known as allyl halides. Allyl halide. Then what do you mean by vinyl halide? Vinyl halide means nothing but, suppose you have a haloalkane. Okay. So the halogen attached to exactly sp2 hybridized carbon. Okay. Simply we can say halogen attached to a double bonded carbon. Then we can say that is vinyl halide. Okay. Many times in MCQs they ask like, the compound is allyl halide, vinyl halide, and one more classification, that is benzyl. Okay, what do you mean by benzyl halide? In benzyl halide, you have a benzene ring connected to sp3 hybridized carbon and is connected to halogen. So this is actually sp3 hybridized carbon. Okay, so this type of classification is important. Allyl halide, vinyl halide, benzyl halide, and aryl halide. Aryl halide means halogen directly attached to a benzene ring. That is aryl halide actually. Chlorobenzene, bromobenzene, iodobenzene, that kind of thing. Okay. And when you study this chapter, you can see the main thing, SN1 and SN2 mechanism. Okay. The questions can be asked in many different ways. Okay. They can ask, what is the difference between SN1 mechanism and SN2 mechanism? Okay. SN1 and SN2. So here in SN1 mechanism, formation of carbocation. Okay, formation of carbocation is important in SN1 mechanism. In SN2, there is no formation of carbocation. We can say no intermediate. So in SN1 mechanism, tertiary halides are highly stable than secondary, than primary, than methyl. Okay. Moreover, if you have a kind of what I can say, if you have benzyl carbocation is there, benzyl is highly stable, then allyl, then tertiary, then secondary, then primary. So the theory part you should go through. You should go through the theory part also. Okay. And what about SN2 reaction? SN2 mechanism is single step, which is most stable one in SN2 mechanism. Methyl group is highly stable in SN2 mechanism. Then primary, then secondary, then tertiary. Okay, so you please note this kind of reactivity order. Okay, that's actually important. So this is the difference between SN1 and SN2 mechanism. We will do questions. Okay, after this discussion, we will do questions, and we can also ask the questions after the completion of each chapter. Okay. Then many students said that some kind of part is highly difficult in this chapter. Okay, some students said that like optical activity. Optical activity. Optical activity is nothing but take a beaker containing a compound. Okay, a halo compound. Suppose a halide is given. Okay, if you are passing plain polarized light, okay, there is a chance of deviation of plane polarized light either to right side or to left side. This is clockwise direction. This is known as dextro compound. That means a compound which can rotate its path length, okay, which can rotate its path, okay, which can rotate its path towards the clockwise direction or right side direction is known as dextro compound. So what do you mean by levo? Levo means nothing. If a compound can rotate its particular path into anti-clockwise direction or left direction, that is known as levo. Okay, so that is the thing regarding dextro or and levo. And you know, when SN1 reaction happen, okay, in SN1 reaction, for example, if you are reacting to bromo propanol, sorry, to bromopropane with OH minus, there occurs the formation of two propanol. Correct. Here the product will be dextro will be present and levo is present. Okay, both kind of product you will get. Okay, so when you take dextro and levo in equal amount, that is known as racemic mixture. The process of mixing dextro and levo together are known as racemization. So racemic mixture, racemization. Okay, for SN1 reaction. And for SN2, there is no racemic mixture, either dextro or levo will form. Okay, and students, one more thing, we cannot predict which which compound is going to form, like either dextro or levo. We are not sure. Okay, we are not sure which of the compound is going to uh, give the product. Okay, so either dextro or levo, we are not sure. But still, you can see if your SN1 reaction, dextro and levo is possible. Okay, so SN1 reaction can cause racemization or the racemic mix, or we can say the racemic mixture formation. But SN2 reaction is made mainly for the inversion of configuration. Inversion of configuration. Okay, inversion of configuration will happen in SN2 reaction. That means the configuration is just inverted. Okay, that is regarding SN1 and SN2. And you know, the chapter contains almost 7 named reactions. Named reactions are highly important in organic chemistry because in organic, they will ask the name reaction, explain that kind of reaction. For example, the first name reaction of the chapter is Sandmeyer's reaction. Sandmeyer's reaction is actually the conversion of aniline to haloarenes. Okay, so I will not explain all the, all the reactions. I will just note down the reactions. Okay. Then halogen exchange reactions. Which are the halogen exchange reactions? Anyone? 2 reactions are there. Which are the halogen exchange reactions? Okay. Please try to answer which are the halogen exchange reactions. You know,
Synchronicity and
yeah, exactly. So halogen exchange reactions are 2. One is Finkelstein reaction. The other one is Schwartz reaction. Schwartz reaction. Finkelstein reaction and Schwartz reaction. So here in Finkelstein reaction, if you have a haloalkane, if you are reacting with sodium iodide, you can form like iodoalkane. Okay, that is the thing. Okay, so iodoalkane plus sodium X. So with this is Finkelstein. Okay, you can remember Finkelstein like when you write Finkelstein, there is two I is there, right? So it's sodium iodide NaI.
Hello.
This is how I remember the Finkelstein reaction. Schwartz reaction is similar. Okay, Rx plus AgF. There occurs the formation of Rf plus AgX. Okay, that is actually what we can say Schwartz reaction. So Finkelstein reaction and Schwartz reaction is important as the name reaction. Okay, then you can see the next name reaction in this particular chapter. Wood's reaction. Wood's reaction. What do you mean by Wood's reaction? If you have alkyl halide, you can react it with sodium plus alkyl halide. Okay. Then what happened? There was the formation of alkyl group RR plus 2NH. Wood's reaction. Then Fick reaction. Then Wood's Fick reaction. And the important one in this chapter is ampidentate nucleophile or ampident nucleophile. What do you mean by ampident nucleophile? In ampident nucleophile, it can have different, more than one donor site at a time. It will connect with only one donor. For example, if you have an alkyl halide, suppose you are treating with KCN, you will get RCN plus KX. Okay, you can react this alkyl halide with AgCN, you will get RNC plus AgX. So here cyanide group is an ampident nucleophile. Okay, ampident nucleophile. And also the NO2 group. If you are reacting KX, RH plus KNO2, you will get RONO. That means that means oxygen is connected in NO. Oxygen is connected to R plus KX. Then RH plus HNO2, you will get RNO2. Nitrogen is connected with R. Okay, so here NO2 is the ampident nucleophile. And in this chapter, some more things are there. For example, one important question: haloarenes will not substitution reaction. Why? Haloarenes will not undergo substitution reaction in normal condition, but haloalkene will. Why? Here, multiple reasons are there. Here, multiple reasons are there for the haloarenes, which will not undergo substitution reaction. You can think about haloarene. What do you mean by haloarene? An arene group, a benzene group connected to halo group. Okay, so multiple reason is there. So this carbon is actually sp2 hybridized, right? So
Due to partial double bond character, right?
exactly, partial double bond character. Okay, my voice is clear, right? I mean, is there any issue regarding the audibility?
No.
Okay, fine. Okay, so partial double bond character, and this bond length, less bond length compared to haloalkene. In haloalkene, the carbon is hybridized. Okay, so these are some kind of reasons. Now we can go through. Now we can go through some questions of the same chapter. So the first question, just listen. Justify and arrange the following compounds of each set in increasing order of reactivity towards the asked displacement. Okay, so they are asking some kind of. They are asking some kind of we should rearrange the compounds based on their conditions. Okay. For example, first one bromobutane, two bromo, two methyl propane in terms of SN1 reaction. So which is more reactive in SN1 reaction? Anyone? Which is more reactive in SN1 reaction?
So tertiary.
Exactly. Tertiary is highly reactive in SN1 reaction. So you know which is tertiary here. You can see this is the tertiary one. 2-bromo, 2-methyl propane. Think about propane, 3 carbon, 2 methyl. This is your bromine. So this is tertiary halide, correct? Halogen attached to carbon, halogen attached to some, right? Yeah, halogen attached to some carbon, and that carbon is attached to 3 other carbons, right? So this is first, this will have the highest reactivity. Then 2-bromobutane is your secondary, correct? So this one, then 1-bromobutane is the primary one. Oh, butane, sorry, this is propane. Okay. Now, the same thing, but in SN2 reaction. You know, in SN2 reaction, tertiary is the least stable, correct? So the least stable or least reactive. Then you can see secondary, then primary. So here 1-bromopentane will come first. 1-bromopentane, then 2-bromopentane, because 1-bromopentane is the only one primary here. 1-bromopentane, most stable. Then 2-bromopentane, then 2-bromo, 2-methyl in terms of SN2. So SN1 and SN2, you can say it's a sure question. Okay. In every question paper, they will at least they will include an MCQ or an assertion reason. Okay. Or like this kind of question, or simply for 2 marks, write the difference between SN1 and SN2. Okay, so you can include this order of reactivity, even inversion of configuration, retention of configuration, regarding the optical activity, everything you can include in your question paper. I mean, in your answers. Okay, next. So the next question, define the following terms. So this is actually a previous year question. So think about this question. Okay, they are asking, define the following terms. What do you mean by racemic mixture? What is actually racemic mixture? Racemic mixture is nothing. Listen. So racemic mixture is the mixture of, okay, dextro and levo. Okay, dextro and levo in equal proportion, or we can say, generally we can say it is the equimolar means same concentration. Okay, equimolar solution of enantiomers. Okay, so suppose you are taking a solution containing dextro and levo. In textbook, one more definition is that 50 is to 50. Okay, 50 equal kind of half. Dextro and levo is known as racemic mixture, also known as racemization. Okay, racemization or racemic mixture. Next, what do you mean by chiral carbon? Anyone? What do you mean by chiral carbon? What do you mean by chiral carbon?
Is a carbon atom that is
Yeah.
bounded to 4 other groups like that.
Yeah, exactly. The carbon atom connected to 4 different groups. That is actually
Yeah.
chiral carbon. Okay, so if a molecule is said to be optically active, chiral carbon should be present. Okay, if a molecule is said to be optically active, chiral carbon should be present. And in this occasion, I'm explaining one more thing: glycine. Glycine is the only one amino acid which is not optically active. Okay, so this is the structure. It's actually biomolecule, but I'm saying this one here because optical activity. This carbon is not chiral carbon because two groups are same. That means it's not. It's a symmetric carbon. So chiral carbon is also known as asymmetric carbon. Asymmetric carbon or chiral carbon both are same. Okay. Next, what do you mean by enantiomers? Okay, enantiomers means they are stereoisomers. What do you mean by stereoisomers? Isomers obtained by the rotation of the atoms in space, spatial arrangement. They are stereoisomers which have non-superimposable mirror image. Okay, they have same structure, okay, same molecular formula, but what's the thing? In during the spatial arrangement, they arrange in such a way that their mirror images will not superimpose. Okay, their mirror image, like our hand. Okay, in textbook you can see our hand. The mirror image of our hand is your this hand. These two are not superimposable, right? So that is known as enantiomers. Enantiomers. Okay, so we should know the terms and things in NCERT textbook. Okay, so they will ask the exact terms. For example, what is racemic mixture? What is this one? What is that one? That kind of exact terms they will ask. Then next, the correct IUPAC name of the compound. Okay, try to write the IUPAC name. Is very easy. Okay, try to write the IUPAC name of this compound. Anyone? Which one will be correct?
This will be uh, 1
Yeah.
bromo 2,2 dimethyl propane.
Yeah, dimethyl propane. Right. So here is the, yes, correct. Exactly. Very well. Here is the functional group only bromine. So you can start numbering from here. Second carbon contain two methyl groups, CH3, two CH3 groups. So this is propane, exactly propane. So bromine is attached to the first carbon. So you know the alphabetic order is important. One bromo, right? Not two bromo. Alphabetic order is important. Then 2,2-dimethyl propane. So second carbon contains two methyl groups. So dimethyl, total three carbon in the main carbon atom, not ethane, not 2,2,2. Okay, so D is the correct answer. So this kind of easy questions also they can ask. Okay, so be aware of that. Next, next one. Draw the structures of the major monohalo products each of the following. So this is actually for para-nitroethyl benzene, right? So here we are adding bromine in presence of UV light or heat. So this is actually known as free radical halogenation, correct? Very easy. One hydrogen will be removed from here, one bromine will be attached. So nothing happens for the benzene ring, nothing happens for the nitro group. Here CH2 is there, and that CH3 become one hydrogen and bromine will go. Okay, HBr will go out, then CH2Br. Okay, so for nitro, okay, for nitro ethyl benzene become this one. So only one bromine is added. So this is, okay, this one is not a regular one, but this question you can see several times asked. PYQ. Several times this asked. So what will be the answer of this question? You are adding hydrogen iodide to a particular alkene. Right. Always think about Markovnikov rule. Whenever you are adding hydrogen halide to a particular alkene, always think about Markovnikov rule. Markovnikov rule says that the negative part of the adding reagent or the addendum will go to those sides which contain lesser number of hydrogen. Here you can see one hydrogen. Right. Here you can see no hydrogen, right? All the bonds are satisfied by carbon. So the negative part will come here. So that what will be the product? The double bond will break. Correct. Then CH3 here, nothing will happen. You know, hydrogen will add here. Okay, we will not show hydrogen. Iodine will be here. So this will be the product. Suppose if they are adding hydrogen iodide in presence of peroxide, what will be the change? If they are adding hydrogen, okay, hydrogen iodide in presence of peroxide, anti-Markovnikov rule will be satisfied. Okay, the iodine will go to that particular carbon. Okay, so this question you can see several times they asked in CBSE question paper. So, and also one more thing, students, organic chemistry, I cannot say 100%, but still 80 or 85% they will take from previous year. Okay, but numerical they can do many things like for kinetics, for solution, the questions. But for organic, most of the questions are repeatedly asked. Next, the dipole moment of chlorobenzene is lower than that of cyclohexyl chloride. Okay, let me draw the structure of chlorobenzene and cyclohexyl chloride. The dipole moment of chlorobenzene. So this is chlorobenzene. This is cyclohexyl chloride. Okay. So the dipole moment, what do you mean by dipole moment? Dipole moment we studied in 11th. What is dipole moment? This is carbon and this is chlorine. So the dipole moment will go from here to chlorine. Dipole moment direction, right? Should be a straight line from carbon to chlorine. From carbon to chlorine. Okay, so they're asking the dipole moment of chlorobenzene lower than that of cyclohexyl. And how can you explain this one? How can you give a correct explanation of this question? Anyone? Anyone? Listen. This is actually sp2 hybridized carbon. This is sp3 hybridized carbon. Correct? So always think the electronegativity of sp2 hybridized carbon is more than sp3 hybridized carbon. So here the electronegativity difference between this carbon and this chlorine is less. Okay, the electronegativity of sp2 hybridized carbon is more than sp3 hybridized carbon, and the difference between the electronegativity between carbon and chlorine is less comparatively in chlorobenzene than cyclohexyl chlorine. So the dipole moment is lower, dipole value will be lower in chlorobenzene. Okay, that is an important concept. The electronegativity of sp2 hybridized carbon is lower. Least electronegativity for, sorry, highest electronegativity for sp hybridized carbon, alkyne. Okay, but you know, sp2 have more electronegativity than sp3. So the chlorine, you know, both are same. So chlorine electronegativity, that difference is less in chlorobenzene. So that we can say its dipole moment value will be. Is it clear? Please respond. If you have any confusion, I can explain it again. Is it clear?
Sir, can you explain once more?
Okay, sure. Here, you know, the carbon, this one is sp2 hybridized. This is sp3 hybridized. So, you know, the electronegativity of sp2 hybridized carbon is more than the electronegativity of sp3 hybridized carbon. So this one have more electronegativity comparatively this one, but chlorine are same. So the electronegativity difference between this carbon, sp2 carbon, and chlorine is very less. Fluorine is the highest negative element. After that, chlorine. So chlorine and this carbon have a very slight difference in electronegativity, so that its dipole moment will be less. Clear? Is it clear?
Yes, sir.
Okay. Now we can move on. We can move on to the next question. Alkyl halides are immiscible in water. Why alkyl halides are immiscible in water? Alkyl halide, 2 or 3 reasons are there. Still, alkyl halides are non-polar compound. Non-polar, but water is polar compound. You studied in solutions. Polar compound will dissolve in only polar compound. Okay. Or we can say it cannot make hydrogen bond with water. It cannot make hydrogen bond or any kind of interaction. Okay. Next, tertiary butyl bromide has lower boiling point than normal butyl bromide. Okay, let me take tertiary butyl bromide. What do you mean by tertiary butyl? Tertiary means one carbon attached to 3 other carbons. Tertiary butyl bromide and normal butyl bromide. Okay, so you can see what is the point here. This one have the lowest boiling point. This one have the lowest boiling point than normal butyl bromide. So what is the concept? The boiling point is inversely proportional to branching. More the branching, less the boiling point. Okay, if the branching is very less, it's very interactions are less, so it's easy to break, and also the boiling point will be less. Okay, so this is the concept. And the same question they can ask, they will give some random compound and they will ask, arrange the following in the increasing order of their boiling point. Always think, if you have the least branching, then the highest boiling point. Okay. Next, so these are the main questions we discussed in haloalkenes and haloarenes. Now it's like let it be an interactive session. Okay, you can ask any doubts from haloalkenes and haloarenes, like any questions or any doubts or any questions you met. Okay, you came across in your past papers or textbook or notebook. Any doubts in this chapter or any portion? You can suggest a portion.
Sir, can you explain dextro and levo?
Okay, okay. Okay, dextro and levo. Dextro and levo, these are optical isomers. Optical isomers. That means they are showing some optical activity. Okay, there are stereoisomers. Stereoisomers are of different type, and like geometrical isomers are there, optical isomers are there. Okay, we studied in coordination, cis and trans, they are geometrical isomers. Similarly, dextro and levo are optical isomers. They have some optical activity. Nothing. Suppose at the starting of the class, we just explained, like if you have a compound in a beaker, you are passing a plain polarized light. That means it will vibrate only in one direction. There is a probability this molecule can rotate this light to right or left. If it is rotating towards light, that is known as dextro. And if it is rotating towards left, that is known as levo. Dextro and levo, these compounds looks like same. Their structures are same, but they are non-superimposable mirror images. We can say they are enantiomers. Enantiomers means non-superimposable mirror images. In exam, they will not ask whether the compound is dextro and levo. No, that kind of question we can't expect, because this concept is exactly based on the experiment. Experimentally, for example, glucose is dextro. Glucose is dextro. We can't question that why glucose is dextro. So that is the experimental result. And fructose is levo. Okay, fructose is levo and fructose is levo is a statement. Okay. We can prove it by experiment, but we can't do anything by theory. Okay, and the thing is, when you do the SN1 reaction, sometimes you will get the mixture of dextro and levo. Okay, and we will say that they are okay. We will get the racemic, that is known as racemic mixture. That means there is a probability of formation of dextro and levo. Okay, so that is the concept regarding dextro and levo. Clear?
Sir, one more type of question.
Yeah.
Um, it will ask like which among the following will go SN1 or SN2 reaction faster.
Yeah.
So how do you really identify it?
Okay. So for SN1, if they are asking SN1 reaction, tertiary, if there is a tertiary halide, that will have the maximum reactivity. Okay. Tertiary, secondary, primary. In SN2, just reverse. Primary, secondary, tertiary. Okay. After that, methyl will be there. Okay. So this order we should study. And we've got a question from Hajara Ali. Okay, this one is clear, like Atman.
Yes, sir.
Okay, Hajara Alim have a question. An optically active compound having molecular formula C4H9Br. Okay, C4H9Br. Okay, when treated with aqueous KOH, okay, fine, gives a compound with a racemic mixture. Identify and view the mechanism. Okay, so this was a question I got from the live chat box from YouTube. Just answer that. Okay, this was a very nice question. And this question, you can see the same question, you can see sample paper of CBSE 2024, 2024, yeah, 24 year. I mean, the same kind of question in target for star target student, we did the same question. Hope you remember. Anyway, so they asked C4H9Br. Okay, so C4H9Br in aqueous KOH gives a racemic mixture. Racemic mixture. Wait. So this is the information. So the molecular formula is given, aqueous KOH is given, racemic mixture is given. Now you can say racemic mixture will happen only if the reaction happening in SN1. And your halide should be secondary halide. You please note that if the question it is given racemic mixture, we can confirm that the mechanism is SN1. Okay, and your halide is secondary halide. So you can start from CH3, CH, CH2, CH3, Br. This is your C4H9Br. Okay, you are treating with aqueous KOH. Aqueous KOH contain OH minus ion. In SN1 reaction, the carbocation will form first. So CH3, CH, CH2, CH3Br is removed. So you will get a carbocation. Okay. In the next step, actually you can write it in one more time. I'm writing like OH minus. I'm writing here. So you know there are two probabilities. Okay. So CH3, CH OH, okay, CH2, CH3. Okay, this is actually first formation of carbocation. Okay, this is second step. So this is the rate determining step or slow step. Okay, then you will get this one. This is actually plus or minus. Plus or minus means dextro and levo you will get. This is known as. So how to identify the question? If it is racemic mixture and if they are saying the racemic mixture word, it should be SN1 and second. Is it clear? So this was a very nice question asked in CBSE sample paper.
Sir, why KCN forms cyanide and AgCN form isocyanides? Many questions, many times it came in exam, but I couldn't answer.
Okay, exactly. So here, why is the question? Why CN form KCN? Okay, when you react alkyl halide with KCN, form, we will get cyanide, alkyl cyanide. So RH plus AgCN, you will get RNC, isocyanide. Okay, so why this is happening? Okay, because due to cyanide is a anti-dent ligand. This is the reason this one happening. This one happening due to cyanide. The same thing happening due to for NO2 also. This is an anti-dent ligand. Okay, that is the only answer they are expecting from you. Okay, like anti-dent ligand. Some other reasons are there due to the bonding between potassium and cyanide. That is an ionic in nature. Okay, due to that carbon will donate more than nitrogen. Okay, that kind of there. But according to the grade level student, they are expecting the answer like CN minus, NO2 minus. These kind of ligands are amphibian. They can bond two donor atoms, but at that time it will bond with only. Clear? Yeah. Zohara, have any question? Zohara, you can unmute and
Sir, I'm unable to hear you properly. Your voice is breaking in between.
come again.
I'm unable to hear you properly, sir. Your voice is fading off.
Okay. Any other students have the same situation? Kind of voice is breaking or something?
So for me also.
You also. What about others?
Yes, sir.
Let me check this. Is it audible?
Yeah.
Yes, sir.
Okay, fine, right? Now? Okay. So I think now we can hope one more thing. Actually, not ambient ligand. Don't write ambient ligand. Ligand is actually in coordination compound. Here we can write nuclear. Okay. Okay. Okay, fine. Now we can move to the next chapter. I think. Have any other question? If you don't have any other questions, okay, no problem with audio. That's fine. Okay. So the next chapter is alcohols, phenols, and ethers. Okay. And basically, basically the preparation of alcohol is important. And I can say, students, three mechanisms are important. At least one mechanism will come for exam. Very important mechanisms. Very important. At any course, you should study. You can by heart or you can study it. You know, very few days, I mean, 2 or 3 days are there. That I'm saying. Mechanism, acid catalyzed hydration. Hydration. That is alkene to alcohol conversion. Okay. Or only three mechanisms you have to study. Or alcohol to alkene. Dehydration. At 443 Kelvin. Okay. Third one, alcohol to ether. Dehydration at 413 Kelvin. These three mechanisms. Any of one mechanism, any one from these three will ask. Sure. Anyone. Okay, any one of these three will ask as a part of mechanism writing. Other mechanisms we can study, but it's not important. Okay, so similarly, you can study it. Okay, no other importance. And also, always remember the acid catalyzed hydration follows Markovnikov rule, and hydroboration oxidation follows anti-Markovnikov rule, that kind of things. Then the acidity of alcohol. Acidity of alcohol. What do you mean by the acidity of alcohol? For example, suppose they have randomly give, think about CH3, CH2OH, CH3, CH3, C, CH3. So all are alcohol, right? This is primary alcohol, this is secondary alcohol, this is tertiary alcohol. So tell me, which is the highly reactive, okay, highly acidic alcohol here? Which one is the highly acidic alcohol?
Tertiary.
No, tertiary is not the highly acidic. Any other answer?
Primary.
Yeah, primary is highly acidic. Okay, always think electron donating group for all. If they're asking alcohol or carboxylic acid or amine, anything, electron donating group will decrease the acidity, but it will increase the basicity. Electron donating group like alkyl group, ethyl group, methyl group, it will decrease acidity but increase the basicity. But electron withdrawing group increase the acidity and decrease the basicity. Study anything, either acidity or basicity, then accordingly think about the other. So anyway, electron donation will decrease the acidity, electron withdrawing will increase the acidity. For you can say this ethyl group is a good electron donating group. 3 electron donating are present in tertiary. So tertiary is least acidic than secondary. Sorry, least acidic in the sense. Got it. Sorry. Tertiary is least acidic than secondary than primary. So primary alcohol, secondary and tertiary, primary alcohol is highly acidic. So because CH3 group is an electron withdrawing group. 3. Okay, so this is the concept. You can take a screenshot of this slide fast. Next. Okay, think about phenol. Then paranitrophenol. Then paramethylphenol. Which is highly acidic? Anyone? Which is highly acidic?
Sir, para-nitrophenol.
Yes. Always think nitro group is electron withdrawing group, methyl group is electron donating. Right. So we can say this is first, this is second, this is third. Okay. So paranitrophenol is highly acidic. Okay. Then phenol, then methyl nitro, paramethylphenol. Okay, the acidity part is actually okay. And also phenol is highly acidic than normal alcohol. Okay, because due to the resonance factor, phenol is highly acidic. Okay, then as I told you, named reaction have certain role in this chapter also. Okay, the named reaction is like Riemann-Tiemann reaction many times in every exam. Riemann-Tiemann. Starting from phenol ends at salicylaldehyde, orthohydroxybenzaldehyde by adding chloroform and sodium hydroxide. Okay. Then Cope's reaction. And repeatedly asked, Lucas test. Lucas test is used to identify primary, secondary, and tertiary structure. Tertiary alcohol. Okay. Lucas reagent is Anhydrous zinc chloride and HCl. So all things are important. Okay. Then regarding acid catalyzed hydration, hydroboration, oxidation, that kind of reactions are still there. Okay. And Cope's reaction is important, right? Phenol to salicylic acid conversion, orthohydroxy benzoic acid. Okay. Then the reaction of phenol. Okay, phenol is over. Then either Williamson either synthesis is the main thing. Williamson synthesis or Williamson ether synthesis. And always think Williamson ether synthesis follow SN2. I think some question is there in the last year. In 2024, they asked which mechanism is followed by the Williamson ether. Okay, I think Williamson ether synthesis is happening from alkoxide plus alkyl halide. Na will take chlorine. What is remaining? ROR. Ether is formed with sodium chloride. So this kind of named reactions are exactly important. If you are not good in organic chemistry, suppose you are not good in organic chemistry, have a feeling that I will fail in organic questions, just go through today itself, go through all the named reactions. Okay, I can say 100% from that name reaction, there will be at least 5 or 6 name reaction will be there in you. Okay, so at least I'm saying the minimum number. I will show you the proof. Okay, so at least you have 5 or 6. If you are not, if you have a thought that you are not good in organic, just study the name. Is a good condition. Okay, I think the total of 15 name reactions are there. From that, 5 or 6 name reactions pakka. Okay, so let's do the questions. The first question. Orthonitrophenol is a weaker acid than paranitrophenol. Correct or not? Anyone? Orthonitrophenol is a weaker acid than paranitrophenol. Correct?
Yes, sir.
Yes, exactly. Orthonitrophenol is weaker acid. You studied, okay, in any organic chapters you studied para. What do you mean by para? Para means opposite, right? This is ortho. And this is para. Para means OH here, NO2 here. So, you know, para is more acidic. And about the reason. Sir, could you tell me important question from aldehyde chapter? Oh, sure. After completion of alcohols chapter, we are going to aldehyde chapter. Okay, we will complete alcohols chapter. Okay. So here, what is the reason? Intramolecular hydrogen bonding makes para isomer stronger acid than orthoisomer. What do you mean by intramolecular? Intramolecular hydrogen bonding means bonding between the atoms in the same molecule. So intramolecular hydrogen bonding is present in ortho, but absent in para, right? So intramolecular hydrogen bonding makes para isomer stronger acid than orthoisomer. So actually wrong. Intramolecular hydrogen bonding is not present in para. Intramolecular. The atoms, the hydrogen atom and the highly electronegative atom in the same molecule are making some bonds, some interactions. That is intramolecular. So orthonitrophenol will, you know, okay, orthonitrophenol will actually, they will make intramolecular hydrogen bonding, but para will not. So the assertion is true, but the reason false. Next, name the reagent used for the conversion of the following reaction. Bromination of phenol. Yeah. Bromination of phenol to 2,4,6-5-bromophenol. Anyone can say the converting reagent? How will you convert?
Water.
Yeah, exactly. Listen, just listen to this point. You need 2,4,6-tribromophenol, correct? If you need 2,4,6-tribromophenol, you should add bromine water. Okay, so you should add bromine water. Bromine water. Okay, Br2 in water. Suppose they are asking, we need only para-bromophenol. Suppose they are asking, we need only para-bromophenol. What will be your reagents?
Br2 in CS2 something.
Yeah. Suppose, listen, this point is important. You have phenol. If you need, this is actually uncontrolled bromination. This one is uncontrolled bromination. Bromine in a polar solvents like water. If you are adding bromine in a non-polar solvent like CH2 or CCl4, you will get para-bromophenol. Easy concept. Auto and para will get para is the major. Okay. Now, how will you convert butane 2 on to butane 2-ol? Is it oxidation or reduction? Is it oxidation or reduction? 2 on to 2-ol. Anyone?
Oxidation.
Sure. Actually, this is reduction. How to identify whether it is oxidation or reduction? Just draw the structure. Butane 2 on CH3, second carbon on ketone, CH2, CH. Butane 2-ol means CH3, C, H, O, H, CH2. Okay, so we want to reduce it. Reduction, addition of hydrogen. What is the change? 2 hydrogens are added. So no need to study, no need to buy heart it. If you want reduction, you can use reducing agent. Okay, simple reducing agents like
Lithium aluminum hydride.
yeah, exactly. Sodium borohydride or lithium aluminum hydride, you can reducing agent. Just add the reducing agent towards the ketone. Clear, that's a good reducing agent. Okay, I hope it's clear. Now we can see this is the reason, this is the proof. Okay, explain the following. They are asking Riemann reaction, Gauss reaction, Williamson reaction. Not explaining actually and showing. This is actually I have snipped this. I mean, I have cropped the image. Okay, from the previous year, just previous year, 2024 question paper. Okay, so this is officially CBSE officially 24 question paper. Okay, so Riemann Cox Williamson synthesis, there are repeated questions. Okay, I can say any one from these two will ask. Okay, any one from these, any two from the three. So prepare accordingly. Now the question that I discussed, Williamson synthesis is preparing dimethyl ether is A or and electrophilic substitution SN1 electrophilic addition is actually note it down. Williamson synthesis is actually N2 fast reaction. We studied. Okay, if your alkane halide is a primary or secondary, the reaction will be faster. If it is tertiary, it will be very slower due to SN. Next. And you can expect a question like Grignard reagent. Grignard reagent question. Okay, very easy. So you have a Grignard reagent RMGX. Here the R is cyclohexane CH3CHO. I'm drawing the structure of CH3CHO, CH3, C double bond O, and H. You are treating with okay. So instead of this big one, I'm writing cyclohexyl MgBr. At the end, I will put the structure. Okay. So what will happen? So this is positive and this will be negative. Correct. So this will attack this carbon. This bond will shift towards oxygen. So Grignard reagent reactions are very important and easy to. Okay. So CH3, C, this cyclic group will cyclohexane group will attack here. Then this become OMGBr. This will become H. On hydrolysis, what will happen? H plus will replaced by MgOMGBr, right? So I mean MgBr. So you will get CH3, C, cyclohexane group. Okay, then OH, then H. This will happen. Okay, Simply we can say product. So Grignard reagent reaction is highly important. Please study Grignard reagent. This is very okay. Simply take a random carbonyl group and Grignard reagent, or they will give the product, and they will ask which is the Grignard reagent here. Okay, that also they can ask. Okay, now this one. Phenol is filled with concentrated HNO3 H2S. What will be the reaction? Phenol with concentrated HNO3. What will be the reaction? Anyone?
Nitration.
Trinitrophenol.
Yes, nitration reaction. Correct. So you are expecting meta-nitrophenol. Sorry, ortho and para. It's a major. Okay, ortho and para. So OH, HNO3, H2SO4. You will get ortho and para. I'm writing only major. You can also write para. Here we can write ortho also because intramolecular hydrogen bonding is there. So ortho and para is fine. Okay. Next, anisole in presence of unhydrogen CH3. What will be the name? What is the name of that reaction? Anyone? Regularly we study in every organic chapters and hydrous LCl3 kind of reaction. Friedel-Crafts acylation. Correct? Friedel-Crafts acylation. What is anisole? Anisole is ether. Anisole is ether means benzene connected to OCH3. Treating with CH3COCl. In presence of AlCl3, what will happen? This COCH3 will join to the ortho and para position. Friedel-Crafts acylation. Then propan-2-ol is copper. You will get propan-2-on, that is copper in 573 Kelvin. That reaction you should go through alcohol to ketone conversion or alcohol to carbonyl group conversion. Propan-2-on you will keep on. Next. Okay. Now you can ask your doubts from either questions or any of the things regarding this chapter, alcohols, phenols, and ether. If you don't have any question, we can. So let it be interactive. You can ask your including conversion. Okay, including the kind of reaction or any give reason kind of questions. I have taken the important one, like the important in the sense, this is actually a core, a cream of the chapter. Okay, like the main thing in that chapter. If you have any doubts? Any doubts or any questions? Maybe a question, maybe you came across, maybe you didn't get the answer yet. Okay, maybe you need the help of it. You can do it. Any doubts? You can unmute and say, or you can put in Q&A.
So if they ask us to distinguish between phenol and one propanol or ethanol and dimethyl ether.
Yeah.
So
Okay.
like
So how to do that type of questions? Okay, that's a very good question. Distinguish type of, this is the thing. Okay, you may came across this kind of question before. That's very good question. So suppose they have given phenol and they have given ethanol or methanol, whatever, an alcohol. How will you distinguish? Multiple kind of methods are there. Okay, so phenol, there is a test. Okay, in your lab, in your practicals are already over. you studied a ferric chloride test. If you don't study, just remember that. Okay, like in phenol, you should add FeCl3, ferric chloride. Okay, when you add ferric chloride, you can see instead of chlorine, this phenoxide group will attack here. Okay, like FeOCH. PH means phenol. Okay, phenyl group. This is a violet precipitate. Violet or blue, depends. Okay. When you react this one with FeCl3, nothing will happen. No precipitate, no coloration. FeCl3 has a kind of reddish brown color. Okay, it's very difficult to identify the precipitate. Even if, okay, kind of coloration will be there, but here there is no coloration. This reaction is not mentioned in textbook, but the point of view, this kind of thing is mentioned, how to distinguish this one and that one. Okay. Suppose they are given, okay, they are giving, okay, aliphatic and aromatic. They will ask. Okay, suppose they are giving an ethanol and ethanoic acid. How will you distinguish? Okay, add base to it. Base means like NaCO3. You know, acid plus base, you know, there occurs the evolution of carbon dioxide gas, brisk effervescence gas. When you add NaCO3, nothing will happen. No brisk effervescence. Brisk effervescence, you know, in carbonate test you studied in pills. When you add dilute HCl to carbonate, there occurs some kind of brisk effervescence. Okay. That was a good question. Any other questions like this? Questions or doubts? Anything from regarding this chapter? Otherwise, we can move to the next.
No, sir, no doubts.
Okay. So I hope you don't have any doubt. Things chat box or Q&A or not, please. You think so? We can move to the next chapter. The next chapter is the biggest chapter in organic: aldehydes, ketones, and carbons. Okay. First of all, its named reactions are important. Which are the named reactions? Rosenman reduction, many times asked. Rosenman reduction means you are converting an ethyl chloride CO to aldehyde group using palladium barium sulfate by adding hydrogen. I mean, palladium and barium sulfate are catalyst, adding hydrogen. Okay. Then Stephen reaction. Stephen reaction is not regularly asked, but still, I think in 1 or 2 years it's asked. 2020, 2021 question papers. Stephen reaction, stannous chloride, right? SnCl2 bar HCl, they are adding Stephen reaction. Then very important reactions regarding this chapter is aldol condensation or cannizaro and cannizaro. Aldol condensation and cannizaro. Any of this one you can see in that Thursday's question paper. Either aldol or cannizaro. Okay. Mostly, sometimes they will ask both. Sometimes they will have something regarding to aldol or cannizaro. Okay, aldol reaction and cannizaro reaction. Then regarding the aldehyde, which are the important reactions, including iodoform tests. Iodoform test. What is the condition of iodoform test? COCH3 group should be present. Regarding that, MCQs you can expect. Which of the following, I mean, they will give some random compound. Which of the following will respond towards iodoform test, or which of the following will respond to, I mean, give the yellow precipitate of iodoform to the compound containing CH3 pure or COCH3 group. What is the condition for iodonic condensation? At least one alpha hydrogen present should present. For cannizaro, no alpha hydrogen is present. No alpha hydrogen. Okay. So that kind of. Then regarding the carboxylic acid, HBZ reaction is important. HBZ reaction. Then full name Hell-Volhard-Zelinsky reaction. Hell-Volhard-Zelinsky. That is the alpha halogenation reaction. Okay, and some unnamed reactions, but are important. Important also bioenergetics like this carbonyl group. Okay, always think aldehydes are more reactive than ketone. Okay, that kind of can expect. They will give some random code which is most reactive. Aldehyde is always more reactive than ketone because ketone contains two aldehyde group, which is a bulky group. The nucleophile cannot easily. So nucleophilic addition reactions are very common in carbon, either aldehyde or ketone. So nucleophile like Cn minus will easily come and attack in the formation of alcohol. You will get an alcohol H nucleophile. This kind of reactions are very common in carbonyl compounds. Okay. Yes. Then in named reactions, reduction reactions are highly important. Reduction means mainly Clemmensen reduction and Wolff-Kishner reduction. Wolff-Kishner reduction. Clemmensen reduction is the conversion of carbonyl group. Clemmensen reduction is the conversion of carbonyl group into hydrocarbon. Simply think about CH3, CH3. You can convert to propane. Conversion questions are highly important. Okay, so CH3, CH2, CH3 will convert to CH2. What is the reagent? For Clemmensen reduction, zinc amalgam in presence of concentrated HCl. Okay, for Wolff-Kishner reaction, for Wolff-Kishner reduction, the same reduction process, same thing will happen. Wolff-Kishner. This is Clemmensen. The reagents are hydrazine, NH2, NH2. Then ethylene glycol and KOH. Ethylene glycol and KOH. Ethylene glycol, KOH. So the same reaction will happen. Okay, and regarding this chapter, importance goes to the acidity of carboxylic acid. I told you before, the acidity will increases with increase in, electron withdrawing group will increase the acidity. Okay, and one more thing, if you want to oxidize, okay, CH3, suppose you have an alcohol. If you want to oxidize aldehyde, which reagent is better? If you want to oxidize ethanol to ethanol, which reagent is better? Anyone? This is actually oxidation reaction, correct?
CrO3.
CrO3 means the Jones reagent, that's fine. Then, very important reagent is there, we will not notice normally, but regularly asked. Which one?
PCC?
PCC.
Yes, PCC. PCC, the full form is pyridinium chlorochromate. Okay, many times asked this PCC. Okay, PCC is an important kind of reagent which can convert a primary alcohol to particular aldehyde. Okay, so that is the thing. Then the acidity of carboxylic acid. Okay, acidity of carboxylic acid includes kind of, for example, they will ask acetic acid or fluoroacetic acid. Which is more acidic? Acetic acid or fluoroacetic acid? You can say fluoroacetic acid is more acidic due to the electron withdrawing to fluorine. Okay, that kind of questions are asking, especially in case study questions. Okay, case study aldehydes and ketones, electrochemistry, and biomolecules. Okay, mainly these chapters are there in case study. Mainly, okay, they will change. Solutions are there. I mean, most probably these chapters will be there in case study. Okay, so that are these are the things regarding this chapter, and many reactions are there, but same kind. For example, what will be the reaction of propanol with 2,4-DNP? What is 2,4-DNP? Propanol means CH3, C double bond O, CH3. What is 2,4-DNP? 2,4-dinitrophenylhydrazine. Phenylhydrazine means benzene connected to NH. Okay, and this connected to NH2, 2,4-dinitro. This is known as Bosch's reagent. Okay, then you know there is the removal of H2O. Other things just join together. So you will get CH3, C double bond. It's connected to N. Then connected to NH, connected to 2,4-dinitro. This is known as, yeah, this is 2,4-DNP test. So aldehyde as well, ketone will give this 2,4-DNP test. Okay. Then you can see many times they asked regarding the semi-carbazide. I think at the end of that reactions, you can see question, can be biomolecules? Can be, Abel, do you mean, can we discuss the biomolecules after this, right?
Yes, sir, that one.
Yeah, sure. After that we can discuss. Okay, then what do you mean by semi-carbazide? Many times they ask regarding semi-carbazide. Anyone? Any idea what is semi-carbazide?
NHCO,
It is actually, yeah, NH2, C double bond O, NH, NH2. You can see two NH2 groups, correct? You know, NH2 groups contain lone pair of electrons, but this will not donate. Many times asked, give reason. Why? One NH2 group in semi-carbazide is not ready to donate its lone pair of electrons. Why? Because it is in resonance with CO. Okay, but this will donate. When you react with a carbonyl compound means C double bond or compound, either aldehyde or ketone, this H2O will remove. The other things you can join together. So NH2, C double bond O, NH, N double bond O, double bond C. Okay, then this is known as semi-carbazone. Many times they ask regarding the semi-carbazide and 2,4-DNP. Okay, you can see many reactions are there in our note and textbook, but this is very important. Study the structure of semi-carbazide, and they will ask why this NH2 is not donating, because they are in resonance with the nearby. So it will. I hope it's clear. Next. Next one. Any other concept regarding this nucleophilic addition? And also, benzaldehyde is a meta-directing. Suppose if you have benzaldehyde and benzoic acid both, if you have benzaldehyde, if you are treating with nitric acid and H2SO for nitration, you will get meta-nitrobenzaldehyde. Okay, always think that you will not get ortho and para. This is meta-directing. group. Then we can do some question and I will come back to your question, your doubts. Hydrophone test is given by. Anyone answer? May answer this question? Hydrophone test is given by propanol, ethyl chloride, pentanal, pentan-2-on.
Pentanal.
Pentanal. 3, 4, 5. This is pentanal. What is the condition for hydrophone test? You need
CHO group should be present.
No. What is the condition? COCH3 group should be present, not CHO.
Yes.
Here we don't have COCH3 group, correct? This is COCH2, CH2, CH2, CHO, so it will not. So
Pentan 2.
Yeah, exactly. Pentan-2-on will be the answer. You can see pentan-2-on. Okay, so here this is okay. If you are well confident in one question also, okay, this is a common mistake. This is not a great mistake. This is a simple common mistake. If you are well known about an answer, you should draw the structure. You should confirm that the structure contains COCH3. So iodoform test, or else they can give a case study kind of. Suppose 4 compounds A, B, C, and D. Okay, A iodoform test. B will not give iodoform test. We can confirm that A have COCH3 group. B will not have COCH3. Case study also they can ask. Next. Yeah, this is also regarding our Grignard reagent. Predict the product following propan-2-on and Grignard reagent. Very easy. Propan and Grignard reagent CH3MgBr. So what will happen? You know, Mg part is positive, this part is negative. So this will attack this carbon. This will go to this direction. So you will get CH3, COH, CH3 after hydrolysis. Okay, H3O plus. This is CH3 and CH3. Okay, some question. Okay. Yeah, I forgot that. Can you please explain tolerance and Felling's test? Sure. Okay. So zinc amalgam. Okay, I will discuss this after that. Zinc amalgam and considered HCl. What is the reaction? What is the name of this reaction? Very famous reduction reaction. Clemmensen reduction. Carbonyl group convert to CH2 group. Okay. Now, okay, as Hajara said, this tolerance test and Felling's test. Tolerance test is actually the reagent ammonia film silver nitrate solution. Ammonia film AgNO3 solution. What do you mean by ammonia? Ammonia containing silver nitrate solution. Okay. Felling's test. Felling's test contain two kind of solution. Both solutions should be added in Felling's test. Okay. Felling's solution A, Felling's solution B. Felling's solution A is copper sulfate solution. Felling's solution B is sodium potassium tartrate. Sodium potassium tartrate. You know, at the end of the reaction tolerance test, you will get a silver color, silver mirror. Felling's test, you will get copper oxide, Cu2O, cupric oxide. Okay, you will get a red precipitate. Okay, so who will give this tolerance test? Tolerance test is given by all aldehyde in the sense aromatic aldehyde, aliphatic aldehyde, all aldehyde will give the tolerance test. Felling's test is given by aliphatic aldehyde, it will not given by the aromatic aldehyde. Okay, aliphatic. That is the major difference. Both will not give aldehyde, sorry, both will not give the ketone. Okay, we cannot identify using ketone, but ketone will give negative test. Ketone will not give tolerance test or failing test. So we can distinguish. Suppose you are giving, they have given an aldehyde. How will you distinguish? Using tolerance test. Clear? I hope it's clear. Next. Next one, I'm giving you a random compound. Okay, this is my random pair of compounds. How will you distinguish this compound? Which test is useful here to distinguish this compound? Anyone? Which test is useful here to distinguish this compound? One is pendant 4, other one is pendant 3 on.
Boiling points will be different.
Maybe, but I need a chemical test. Boiling point is actually the physical property, right? But we need a chemical test. I want to see the precipitate or the car change, maybe kind of anything. We need a chemical test. How to distinguish? Easy. Anyone? At least guess it. We studied this type of reaction. I mean,
Aldol condensation.
aldol condensation will not give you any precipitate. No, don't think like that. Simply think.
Sir, for this, I guess iodoform test, right? Or
Yeah, exactly. Iodoform tests.
yeah.
Yeah, exactly. Very good. Iodoform test is the correct answer because you have COCH3 group is present for this compound. But COCH3 group is not present for this compound. This is not COCH3. Correct. So iodoform test is fine. You will get a yellow precipitate. Okay. So this type of questions you can expect. Okay, iodoform test why? Because COCH. Next. Okay, I am showing you any next proof of that my statement regarding the named reaction. 5 marks, they are asking 5 reaction. Wolff-Kishner, hydrazine, ethylene glycol, KOH, conversion of carbonyl compound to uh, what hydrocarbon, CH2. I can say one more thing. They have saying write short form. They didn't mention write the reaction, write the chemical equation. They didn't mention that. So you can just write it. Okay, write it in words. It's fine, but the reagent and the conversion. Aldol condensation, Rosenman reduction, Cannizzaro, HB0. Okay, aldol and Cannizzaro is actually important. Okay, aldol is the condensing two aldehyde group to a single alpha beta.
Sir, in this type of question, even if we write the reaction, will they give the mark?
Sure. Here they are expecting the reaction. Suppose in Wolff-Kishner, suppose you are taking a carbonyl compound, converting to hydrocarbon, and the reagents. That's fine.
Yeah, but the question is short notes, right? That's why I'm asking.
No. In chemistry, short note means the equation. Equation and reagent condition is the short note. Don't expect short note means a paragraph. No. Simply a reaction and its reaction condition. If possible, in lines, you can write here, this ketone is converted to hydrocarbon. Because if you are going to write a paragraph for each 5 questions, you are spending 2 or 3 minutes or 4 or 5 minutes for each paragraph. You are spending a lot of time for a 5-mark question. Each one carry 1 mark. So one reaction, that reaction should contain the reaction condition if temperature specified, that one, or the reagent acid or base or whatever, solvent or whatever, that's fine.
Okay, sir.
Okay. Next. So you should go through the name reaction. So if you are getting a 5-mark question like this, and you think about that, if you studied every questions, I mean every name reaction, if you are getting a 5-mark question like this, you will be very happy in your exam time. Next. Next, okay. What happens when CH3COCl is treated with CH3 twice CD? Okay. Suppose this reaction is actually there in our text. Suppose a student don't know about the reaction. Okay. But I know some basic things. Okay. But that student know the basic things. CH3COCl reacting with CH3 twice CD. You know, this is a metal. This is a non-metal. Metal always like non-metal. Okay, this is a metal in the same category of zinc. So we can say there occurs the formation of CdCl2. What is remaining? Okay, CH2CH3CO remaining. Correct? Then 2CH3 remaining. You can join together. So you will get propanol, CH3, CO, CH3, maybe 2 molecules. Next, CH3CHO treated with HCN. I told you that cyanide CN minus will go to CO. Okay. Then cyanohydrin formation. Benzaldehyde with concentrated HNO3 and H2SO. Metanitro benzaldehyde. Next, which acid in each pair shown below would be? Fluoroacetic acid. I told you fluoroacetic acid due to due to the electron withdrawing group like fluorine. Paranitric acid, paramethyl benzoic acid, paranitro, because nitro group is the electron withdrawing group here. Okay. Let's see. Next question. Which of the following does not undergo aldol condensation? Anyone? Can you answer this question? Which of the following does not undergo aldol condensation? Either A, B, C, or D.
B.
Which one? Yeah, D is the answer. D. Because aldol condensation will undergo which contain alpha hydrogen. What is alpha hydrogen? CH3, CHO. This is the functional group. This is known as alpha carbon. The alpha carbon is the nearest carbon to the group. So it will undergo alpha aldol condensation. Okay, next one. CH3, CO, CH3. This contains 6 alpha hydrogen. So it will undergo aldol condensation. But the last C6H5CHO means benzaldehyde. Here, the nearest carbon contain no hydrogen, so it will not undergo aldol condensation. Right. Again, CH3CHO is more reactive than CH3CO. The reaction with HCl. I told you aldehyde is always more reactive. Okay. Carboxylic acid have higher boiling point than aldehyde and ketone. You know, carboxylic acid have intermolecular hydrogen bonding. This kind of intermolecular hydrogen bonding is present to carboxylic acid. We need more temperature to boil carboxylic acid. Next. Okay, try to do this.
What's the answer of first one? This CH.
This one, CH3 is more reactive than 3.
Why? I think it's
Okay. This one due to CH3CH. Correct? This is CH3COCH. Here you know this is a bulky group. Correct? Approach of nucleophile is difficult, but here aldehyde is more reactive. due to only one party with hydrogen. Clear?
Okay, sir.
Next, how will you distinguish propanol and propanone? Can anyone answer? Propanol. This is propanol. Propanone. Multiple answers are possible.
Iodoform test.
Propanol. Yeah, iodoform test is a very good test for this. Or you can use tolerance test, Fielding's test. All are possible. Okay. Benzaldehyde and benzoic acid. Anyone? Better to do react with NaCO3 like a base. You will get brisk effervescence due to the carboxylic acid. Here, no brisk effervescence. NaCO3 is a mild base, right? So it's not a brisk effervescence benzaldehyde, but carboxylic acid will. Okay. That is the concept. Clear? Okay. Next, I told you the question of semi-carbazide. Acetone is treated with semi-carbazide. Same thing we did. Semi-carbazide. Two molecules of benzaldehyde treated with concentrated NaOH. This is Cannizzaro reaction. One will convert to benzyl alcohol, and one will convert to its corresponding salt, sodium benzoate. This is zinc amalgam concentrated HCl, Clemmenson. Right. Butane 2 won't become butane. Arrange the following in the increasing order of the acidic. Okay. So CH3, CH2. So how will you arrange this one? Which one have the highest acidity? You can go
Fourth
through
one.
these four. Fourth one. Correct. Because here all in 3 compound bromine is attached, but bromine is very near to carboxylic acid here. So the fourth one have the highest acidity. Then third one. Correct. Third. Then this one. Second. Then the last one will contain no kind of bromine. What about this benzoic acid? 4 methoxybenzoic acid, 4 nitrobenzoic acid, 3 4 dinitrobenzoic acid, which is highly acidic. You know, nitro group will increase the acidity. 3 4 dinitrobenzoic acid is the most. Fourth one is the most. Then 4 nitrobenzoic acid, right? Yeah. Then benzoic acid. Then 4 methoxy, because 4 methoxy is electron donating group actually. So electron donating group, you know, will decrease the acidity. Methoxy means OCH3. Clear? Then, okay, next question. Identify the products A, B, C, and D in the following sequence of reactions. CH3, CHO, oxidation. Okay, you will get a compound A. Then PCl5, you will get a compound B. Then CH3 twice CD, you will get a compound C. Then zinc amalgam, Clemmenson. So most Clemmenson means the C will be a ketone. Correct. D will be a hydrocarbon. Okay, let's see. What happens when CH3CHO is get oxidized? Okay, no, sorry, not oxidized, reduced. Listen, oxygen, right? So it's reduced. You will get CH3CH2OH will be a. No. Oxidized. Okay. Aldehyde get oxidized. You will get A will be carboxylic acid CH3COOH. On treating with PCl5, you will get CH3COCl. This is B. On treating with CH3 twice CD, this chlorine and CD will go, CH3 will come here. So you will C will be CH3COCH3. Correct? Finally, zinc amalgam, you will get propane. Okay. Now, how will you convert the propanol to propene? First, convert to alcohol. Okay. By reducing agent, you can convert to alcohol, then dehydration. So, propene. Benzoic acid to benzaldehyde. How will you convert this? Maybe a little bit confusing. Benzoic acid, COOH. You can treat it with SOCl2 or PCl5. You will get acyl chloride. Then you will get Rosenman reduction. You will get benzaldehyde. Okay. Ethanol to butadiene. This is aldol. Aldol condensation. Condense to ethanol. Get butadiene. Clear? Okay. Now I think it's your turn to ask questions now. Okay, you can ask some kind of doubts or questions from this particular chapter. Any doubts? You can also ask in live chat or Q&A session, or simply unmute and ask.
Sir, like in
Yeah.
this chapter, something give reason question came in exam, like why it cannot go Friedel-Crafts acylation. Something it was there in like I don't know the
And that
compound.
is in amines, right?
Yeah.
Amines will not undergo Friedel-Crafts acylation.
Yeah.
Okay, that is, I can explain that reason. Simply take an amine. Okay. Okay. When you add a concentrated, so Friedel-Crafts acylation will happen when you add CH3COCl. Okay. You know, when you are using a very acidic substance like AlCl3, anhydrous AlCl3. You know, this is highly basic. This is highly acidic. It will react each other. It will react together. Okay, so we can see. That kind of reaction, reaction of aniline will not possible. It's not possible due to the acidity of LCl3 and the basicity of this amine. Clear?
Yes, sir.
Okay. 1 minute. Any other question? Any other question from this chapter? Otherwise, we are moving to amines. Okay. Then we can move to amines. Amines. In amine, actually, they will ask regularly. They will ask very few questions. Okay. Regularly, they will ask very few questions. The basic nature of amine. Basic nature of amine. What do you mean by the basic nature of amines? 1 minute. Okay, so the basic nature of amines, always think aliphatic amines are more basic than ammonia, than aromatic. Okay, and in aliphatic amines, for gaseous state, tertiary is more basic than secondary than primary powder. But in aqueous phase, water containing, secondary will be more basic than primary than tertiary. You should note these things. And regarding the test in amines, okay, like the name reaction itself is important in amines. Gabriel Calimán. I'm not explaining, but I'm just saying the name reaction. And Hoffman bromamide. Okay, and ammonolysis test like okay, ammonolysis and test like a Hinsberg test. Okay, Hinsberg test is important. Very important carbylamine test. Carbylamine test only given by the primary amine. Okay. So Hinsberg test is given by primary and secondary. Okay, but carbylamine test is given by primary only. But in Hinsberg test, when you give the product, that product is insoluble in case of secondary, but soluble in sodium hydroxide in case of secondary amine, but insoluble in case of primary amine. Okay, and nitration. The nitration of sometimes they will ask when you nitrate the aniline. Okay, when you nitrate the aniline, think about an aniline. If you are nitrating directly, N, okay. Okay, nitrating directly, this will happen. There was the formation of NH3 plus. Okay, so the direct nitration is not possible. After that, you will get a meta substituted product. This is known as anilinium ion. Actually, when you nitrate aniline directly, this may causes an issue. What is the issue? This may causes like meta substituted product. Actually, NH3 will be orthopara-directing, but at the end you will get meta substituted product. Okay, this issue is overcame by making it acetanilide. We will make it NHCOCH3. Okay, and we will nitrate this one. Then you will get ortho and para. Ortho and para, nitro. Then we will use some kind of base. Then you will get NH2. Okay, please note this one in textbook. You can the nitration of aniline directly when you give. What is the issue? You will get meta substituted. Actually, this will not happen. This is due to the high basicity of aniline and the acidity of nitric acid and sulfuric acid. Okay, I hope it's clear. Then, as important part of this one is diazonium chloride. Many times they asked about diazonium chloride, reaction of diazonium chloride. Okay, time is not. Discuss the biomolecules. Diazonium halide. Okay, always study this reaction. How will you convert diazonium halide to alcohol? Simply heating with water. Okay, how will you convert it into benzene? Many times asked. Okay, how will you simply H3PO2? Okay, and H2O. Then how will you convert this one to fluorobenzene? HPF4. So fluorobenzene. This kind of reactions are certain reactions are important. Okay, if you have any doubts in amines, any other portions in amines, you can ask now. Otherwise, we can discuss the main points in biomolecules. And I know this is a 2 hour sitting at 2 hour chemistry is very difficult, but still, biomolecules also we have to just go through. Okay, so we
Sir,
can move
for
to the biomolecules.
biomolecules, only those 5 reactions and differences between DNA, RNA.
Yeah, biomolecules is least weighted chapter. Give less importance to biomolecules.
Yeah.
Okay, like structure of glucose, both open chain and half.
But sir, in my pre-boards, in both the case study based question, biomolecules, something was there.
Okay, but actually biomolecules is a six, nearly 5 or 6 only weightage in actual board. Which is your school is in Yara?
Yeah.
Okay. So actually biomolecule is the least weightage chapter. But they will ask, in 1 year they will ask have my kind of case study. 1 year kind of MCQ, one MCQ and 1 2 mark. Okay, 3 or 4 mark weightage sometimes. Okay, anyway, go through the structures and the biological functions. Okay, glucose as well fructose. Regarding sucrose, what is important? Inward sugar. Okay, inward sugar and mutation. That means sucrose contains D-glucose, right? Dextroglucose and levofructose. Okay, so these are the things. Okay, these are the things are very important. Mutation, that part. Okay, more important is carbohydrate. And regarding the starch, starch has 2 components: amylopectin. Okay, and how starch is forming due to the linear combination of C1C alpha linkage, C1C6 linkage. Okay, I will give you a short note of a biomolecule. Okay, at the end of the session. Okay, and regarding amino acids, Zwitter ionic form is exactly important. Zwitterionic form. What is zwitterionic form? That is the formation of positive and negative charges in a simple amino acid molecule. For example, an amino acid is actually acid and amino group. Okay, in aqueous solution, it becomes COO minus and CH. This is actually glycine, okay, NH3 plus. Formation of positive and negative charges are known as appearance of existence of positive and negative charges in a simple molecule is known as Victor ion. Okay, like salt. That kind of part, and essential and non-essential amino acid. Example you should study essential and non-essential. And regarding proteins, globular protein, fibrous protein, and always study that vitamin part. Vitamins and one more part is there. Yeah, vitamins and enzymes are not important. Vitamins, that fat soluble vitamins, water soluble vitamins, and the deficiency diseases and its chemical names are also important. Like, for example, the deficiency disease of vitamin A is night blindness. Okay, some deficiency diseases are there, right? 5 to 6. So that, and its chemical name also. Okay. Then DNA and RNA. We said the difference between DNA and RNA. Okay. DNA, what is the difference? RNA, many times. The difference between DNA and RNA. RNA is a single stranded, but DNA is double stranded helical structure, right? Proposed by Watson and Crick. That kind of things are important. Only theory questions. Okay, better to read the note. I will send you a biomolecules note after the session. Okay, you can contact this admin also. Okay, I will send it. Then you please read the notes. Okay, in that note only they will ask, but most of the questions are from that. Okay, I have taken the previous question and I have in that short note. This is simple note, a data 4 or 5 page. Just go through that. Okay, if you have any doubts, you can ask. So give more importance to organic chemistry, and also in every session, at least 2 or 3 questions from organic. So all are interconnected kind of questions. And next, okay, the numerical sessions are not very difficult. You can study the equations and you can do that well. But organic, little bit confusing somewhere. Okay. So do it well. So if you have any doubts, you can ask now, or you can text to the office admin and contact me, or you can directly message. Okay. I think let's wind up now. Okay, you can ask your doubt and prepare well. You have 2 or 3 days are there in front of you, so you can prepare well. Okay, so if you need any kind of note, any kind of questions, either MCQ or any model assertion, reason, 2 mark, 3 mark, every type of question for all chapters are there with me as a single PDF. I can send to you, no problem. So you please text the office admin for that. Okay, no problem. Okay, so all the best. So you can leave now. If you don't have any other questions, you can leave now. Thank you.
Thank you, sir.
Yeah.